Hi guys, good morning. So last class we were discuss about how to construct a engine, types of engines, so some of the components of engines. So all those things of topics we were discussed. Next very important process is turbocharger. So it is a one important process. The kind of process is using for helping increase the engine efficiency. Increase the engine efficiency. So sometimes we could not able to get a proper efficiency from the engine by the engine. So in that cases it is I mean that the turbocharger is most helpful to increase the engine efficiency. So we'll see how the turbocharger is helping to increasing of engine efficiency. As we know that there are more cyclic process are taking on engine: suction, compression, expansion, evaporation. So during suction, the fresh air is admitting into that combustion chamber, and during a exhaust stroke, the exhaust gases, I mean that unwanted gases are removing to the atmospheric. So this is the inlet and exit process, inlet and outlet process. So the kind of exhaust gases are reusing by using of a turbocharger, and we are utilizing the kind of exhaust gases, and by that we are increasing engine efficiency. By that we increasing engine efficiency. Of course, some cases we are using we are using increasing of temperature, increasing of pressure and temperature by suction, and the kind of increasing pressure and temperature of suction air is admitting into that combustion chamber. So that is also one process in order to increase the efficiency of the IC engines. So this is a second process, and this is the another process where we are increasing engine efficiency. So we'll see that one by one here. So first come to the turbocharger. Turbo. Turbo means no turbine. So by using of a turbine, the charging is took place here. So turbocharger or turbo is a turbine driven forced induction device. Turbine is a turbine driven forced induction device that increases an internal combustion engines, increasing an internal combustion engines, right, in order to efficiency and power output by forcing of extra air into that combustion chamber, extra air into that combustion chamber. So that only the exhaust gases are introducing into the combustion, introducing into the turbine blades, introducing into the turbine blades, because the exhaust gases are with some velocity, with some pressure, with some temperature. The kind of velocity, pressure and temperature of those gases, of those of that air is striking to the turbine blade, so that the turbine blades are rotating with that velocity. So whenever the turbine blades are rotating, so that the kind of energy is utilizing to run the compressor. The compressor and turbine shafts are mounted on the same shaft. Whenever the turbine blades are rotating, so that the shaft is rotating, the shaft will allow to rotate the compressor, will allow to rotate the compressor. So up to there, that is the principle. I'll take you that how the working principle is taking place here. Working principle is taking place. Right. A small definition here. Let's see that a small definition. A turbocharger or turbo is a centrifugal compressor powered. So turbine is a centrifugal compressor powered by a turbine that is driven by an engine exhaust gases. So a turbine is driven by exhaust gases. The turbine driven by exhaust gases, so that the compressor is allowed to uh, driven by turbine. So that the compressor is allowed to driven by compressor. So that is the one thing. Next, I'll take you that so history. So as I said that it is a one of the process to increase the efficiency. To increase the efficiency, the proposal was took in the year of 1896. First proposal was took in the 1896. So in that proposal, the intake air was increased. The intake air temperature first try to increase this power of the engine by pressure, by pre-compressing of intake air, by pre-compressing of intake air. So whichever the air is atmospheric air is passing through the intake suction, the kind of air is pre-compressed before entering into that compressor, before entering into that combustion chamber. It should be get pre-compressed so that the pressure and temperature is increasing of that particular air. Then and there it is allowed to pass through, enter into that combustion chamber. Then the second proposal was 1940 1905 1905. So there the turbocharger, this is what we are studying now. The turbocharger was introduced. The turbocharger was introduced. So most of the cases the turbochargers are using in the aircraft engines, because there less amount of fuel has to take, and more power has to produce. Less amount of fuel consume, more power has to provide, or more power has to generate. That is the basic principle, that is the basic utility by the what do you call that, aircraft engines. So in order to increase the efficiency, in order to increase the power of that particular engine, the kind of turbocharger is using in the on aircrafts. So why turbocharger are used here? So it is a basic important question. Why turbochargers are using? So the turbochargers are using the greater mass of air entering into the cylinders on each intake stroke. So every suction stroke, the air is entering. The power needed, the power needed to spin the centrifugal compressor is derived from the kinetic energy of the engine's exhaust gases. So exhaust gases are using to run the compressor, via turbine, by using of turbine, by sending of exhaust gases to the turbine blades, the compressor is running. The turbocharger may also be used to increase the efficiency without increasing power. Increases fuel efficiency, because used to increase the fuel efficiency without increasing power. So turbochargers are widely used in cars. So best example, cars, commercial vehicles, because they allow smaller capacity engine to have improved fuel economy and reduce the emission and high power, and considerably high torque. So to provide the high torque, to give the high power, reduce the emissions, and take the less fuel economy. So these are the some of the factors why we need to use turbocharger here. Some of the factors to use turbocharger over here. Next, come to this. This is the one diagram which I can take you to understand our turbocharger. So by watching up this diagram, by looking up this diagram, by overview of this diagram, you people can easily understand. So as I said that the exhaust gases. So this is the basic principle till now we know, basic principle of this, because this is the engine. On engine, four cyclic process are taking. This is the inlet valve, this is the exhaust valve. From the inlet valve, air is entering, fresh air is entering. From the exhaust valve, from the exhaust port or exhaust manifold, the exhaust gases are going out. So once the exhaust gases are going out to the atmospheric, till now we know that, because we know that the exhaust gases are releasing into atmospheric air. Instead of releasing into atmospheric air, there is a one arrangement, one pipe have been arranged to the turbine. So see here, whenever the exhaust gases are going out, instead of going out, the exhaust gases are moving along inside of the pipe, along inside of the one setup. So because whenever it is passing through that, there is a some velocity, there is a some pressure, and there is a temperature. means that more velocity would be there, more pressure would be there, more temperature also would be there, because those are coming out from the combustion chamber. So whenever the gases are having more velocity, the air is having more velocity, then the kind of velocity is striking to the turbine blades. So this is, as I said that on the same shaft, the turbine and compressor are mounted on the same shaft. The turbine and compressor are mounted here. So when the gases are striking to the turbine blades, these are the turbine blades are there. With high velocity, the gases are striking to the turbine blades, so that the turbine blades will allow to take the revolutions on the shaft. Take the revolutions on the shaft. The remaining